Hey guys, what's up? Throughout this video, you're going to see me swipe down out of the corner a couple times just to make sure that we're still recording and make sure that my mic is still on. I've been having some trouble here. Uh, I've recorded a couple videos like 4 or 5 times, and they either don't have sound or they cut off halfway using the Microsoft whiteboard app. So I'm going to see if it works here. But like I said, you're going to see me swipe down several times just to make sure that it's still recording. So we stopped at a good spot before we left school. We had just finished a chapter. We just wrapped up chapter 2 and then had our third exam. Just came off of pie day, which I'm pretty sure Eddie's pie is still in the refrigerator at school. So that might be interesting by the time we get back. But I guess we'll see. So we're going to roll into logarithms this week. Probably this week and next week. We're going to take it slow. We've got plenty of time to get this done. So we're not going to rush through it. We'll just take it piece by piece, and I'm not going to kill you on problems every day. So that's just the way we're going to do it. So 3.1 has to do with exponential graphs, and that's a waste of our time because it's really not all that relevant. And if we were going to graph it, we would use our calculator anyway, or plot some points and stuff, because it's basically just the exact same stuff that we usually do with our graph transformations and stuff like that. And it's mostly estimating at that point. That wouldn't make Foy happy. He hates to estimate. So we're not doing 3.1. 3.2 also has to do with graphs of logarithmic functions, though. They're not ultra useful either. But in 3.2, there is some good stuff, such as like conversions between logs and exponentials, and then some properties that we're going to go through. So here's what you have to understand about logs. They are directly related to an exponential equation. I'm going to write it out here. It's going to take me a few seconds because I'm going to change colors. So log base b of a is equal to x. Whoa, I don't need that. Is equal to x is our main log formula. Okay, so let me check my microphone just again. Yeah, we're still going. So that's our main log formula. If I want to convert that over into exponential form, okay, it works the same way. And notice when I read that, I said log base b of a. Okay, so all the log, the a, the x, the equal sign, those are all on the same plane, and b is a lowered number. Okay, so that's how a logarithm works. When we convert over into exponential form, that log base b becomes the base of the exponent, okay? And then the only thing you really have to remember is, stop, I do not need that. The only thing you need to remember is the other two things just switch sides. So x comes over to the left and becomes an exponent, and a goes to the other side. And that's what that would be equal to. So for instance, if you had log base 2 of 32, that equals 5 if you type into the calculator, and you wanted to turn that over into exponential form. All you have to do is do 2 is the base of the log, so log base 2 of 32. 2 becomes the base of the exponent, and then the other two things switch sides. So 5 comes to the left, 32 goes over to the right. And if you check it, 5 to the 2 to the 5th is definitely 32. That is our main conversion. You're going to be doing some problems going back and forth between conversions. All right, now I've got a few properties I want to show you. The first one is inverse properties. We've actually got 2 of these. Okay, so number 1 is going to look something like this. If you have me for Algebra 2, you've seen this already, so just hang with me here. If I've got log base b of b to some power, okay, that ends up equaling that x power. The reason is the base number and the whole size number here are able to go away and just cancel each other out, leaving you with whatever the exponent is. So for example, if you had log base 2 of 2 to the 4th, okay, this log base 2 and the 2 are going to cancel each other out just to leave you with a 4. The only weird case about that is what if you had log base 7 of 7, and you're asking yourself, well, what the heck does that equal? Let me make it a log. It looks like 10 OG. You're asking what the heck does that equal? Because the log base 7 of 7 all cancels out. Well, there is an exponent here. We have an exponent on the 1 on the 7 of a 1. So this guy ends up just equaling out to be 1. So our second inverse property, let me check to make sure we're still recording. We are good. Our second inverse property looks something like this. B to the power of log base b of x. That guy also equals x. And the reason is the base b and the log base b and the exponent, those are allowed to cancel each other out as well. So this might come up as saying 8 to the power of log base 8 of 4. Okay, you can type this in your calculator. It's going to output you a number. But these are going to cancel each other out, just leaving you with 4. Okay, you might have 9 to the power of log base 9 of x squared. Okay, that's no big deal. The 9 and the log base 9 are still going to cancel each other out, and it's just going to leave you with whatever you got left up top. Okay, so these logarithm rules are relatively simple, and they shouldn't be that big of a deal. All right, the only other thing that I've got for you is the one-to-one property. Okay, and the one-to-one property looks like this. If you've got log base b of x, and say that's equal to log base b of something else, let's call it y. Okay, essentially these log bases, since they're the same, they're going to cancel each other out. When we start solving equations here in a few days, we're going to see how those are going to cancel each other out. But all you need to know here is that in this case, x equals y, because they're identical on both sides. So for instance, if this was log base 7 of x is equal to log base 7 of y. Okay, for x and y to be equal, which they are here, okay, the log base 7s would be the same. So whatever the number that you're putting in there, if it's going to be equal, it's going to be the same number. So this one-to-one property goes without saying that x equals y. Okay, so those are just some simple properties. Tomorrow we'll probably do that with natural logs, which is going to be really pretty easy again because natural logs don't change much. So like I said, we're going to keep it relatively simple here and relatively short. Let me make sure I'm still recording. Yes, I'm so happy about that. So what I need you to do for me today is page 199, and we're going to do 7 through 22 and 31 through 40. By the way, I'm sure you read this already, but they told us to end the first 9 weeks, the third 9 weeks when we left. So that Friday that we left would have been the end of the third 9 weeks. So I know I told you this was going to be week 9, but I'm actually making this week 10. Okay, so moving forward, it'll be 10, 11, 12, so we'll keep on everybody else's pace. I hope this worked out well for you. I'm going to have to find some kind of whiteboard here that lets me write a little bigger because I ran low on space here. But at least this one did not cut off my video. So let me know if you guys have any suggestions or any concerns or anything. You have my iMessage straight to my iPad. Feel free to message me. You can message the group or you can message me singly. It doesn't matter to me if it really gets down to it. So just let me know whatever you need, and I'll help you the best I can. So good luck. I'll see you guys tomorrow.